Okay guys, so in this video we are going to start with Boolean Algebra. Okay, so first we'll strengthen our basics with the help of the Venn diagrams and then we'll move on to the questions. So let's start with it. Now here we have our two inputs, let's say A and B. Now the common region between these portions is represented by A dot B. Okay, this dot represents that a common region between the inputs is required. Okay, now let's justify the truth table of our AND gate using this Venn diagram. So here we have our input A, input B and output Y. Now for two inputs we'll have four combinations, that is 0 0, 0 1, 1 0 and 1 1. Now as we know, the output of the AND gate is high only when both the inputs are high. So this will be high and the rest will be 0. Now let's verify it using the Venn diagram. Okay, now the first input is 0 and the second input is also 0. Now what is common between these inputs? 0 is the only thing that is common between them. So the output is 0. Now what is common between 0 and 1? 0 is the only thing that is common between these two inputs. So the output is 0. What is common between 1 and 0? 0 is the only thing that is common. So the output is 0. Now what is common between 1 and 1? 1 is common, so the output is 1. Okay, so this was a verification of our AND gate using this Venn diagram. Okay, now let's move on to the next one, that is OR gate. So here we have a Venn diagram and here we have our two inputs once again, A and B. Now what is represented by this? This is known as OR, A or B. That means the whole portion, this whole portion comes under A or B. Okay, if it is difficult to understand from this point, let's try to understand it using the concept of sets. Let's say we have first set as 1 2 3 and the second set is 3 4 and 5. Now if I say S1 or S2, what will be the answer? It will be 1, that is this one, now 2, okay, now 3. Now we have a 3 here but it's already covered, so the 3 will remain as it is. Next one is 4, the next one is 5. Now you can see all the elements are covered in this set, that is covered by the OR one. Okay, so A or B covers every element, but the elements that are repeated are covered only once. As you can see here, 3 is covered only once and distinct ones are covered as well. So similarly, this portion is covered and this portion is covered and this common portion is covered only once. So now let's justify the OR truth table using this Venn diagram. Now here we have our first input A and second input B, the output. Now for two inputs again, four combinations. Now for 0 0, the output of the OR gate will be 0, for 0 1 it will be 1, for 1 0 it will be 1, for 1 1 it will be 1. That is, the output is high when any one of the input is high. Alright, now let's justify it using the Venn diagram. Okay, so 0 or 0, what is the total of this? It is nothing but 0. So what is the total of 0 or 1? Nothing but 1. What is the total region covered by 1 or 0? That is nothing but 1. What is the total region covered by 1 and 1 itself? It is nothing but 1. So this was the justification of our OR gate using the Venn diagram. Okay, I hope I was able to explain this concept. Now we will begin with some questions. So now if I write here A or B, it means the total region covered by the A and B input. Okay, and if I write A dot B, it means the common region, okay, and this means the total region covered by these inputs. Now based on this concept, we'll start with the questions. So the first question is A or 0. Now what is the total region covered by A or 0? It is nothing but A. Let's see it using the Venn diagram. Here we have our input A. Now what is the total region covered by A and nothing? That is only A. Alright, so the answer is A. Now the next question, that is A and 1. Now as I have told you earlier that it represents the common region, common portion, that is. So what is common between A and 1? This whole is 1, that is the whole set. What is common between A and 1? Nothing but A. Right guys? This whole is 1 and this is A. So what is common between this whole portion and this A portion? Nothing but A. So the answer is A. Okay, I hope this was clear to you all. Now the next question, that is A or 1. Now again let's answer it using the Venn diagram. Once you get used to it, you construct the Venn diagrams in your mind and answer it quickly. So here we have our A, this whole is 1. Now the total region covered by A and 1 is nothing but this whole 1. Okay guys, as you can see, I told you in the previous example of this set, that was 1, 2, 3 is our set 1 and set 2 is 3, 4, 5. So if I write it as, if I write the S1 or S2, the output will be 1, 2, 3, 4 and 5. That is, this one is covered, this one is covered, this one is covered, and now the similar one has appeared, but it is already covered. So once only, and then 4 and then 5. So similar is the case here. The total region covered by 1 or A has already covered, 1 has already covered A, so the answer will be 1. Okay guys, I hope you are able to relate this with this question. Now the next question, question number 4th. So guys, we can answer all these questions using the Boolean, using the Venn diagrams. Okay, so the 4th question is A. Now this A and 0. What is common between A and 0? Only 0. If you want to check it using the Venn diagram, let's see it once again. This is A. What is common between A and nothing? Nothing is common, so the output is A. Okay friends, now the next question, A or A. Now the total region covered by, here we have our A, the total region covered by A or A is nothing but A itself, right? A or A is A. Now the next question, that is 6th one, A and A. Now this represents common region again. What is common between A and A? Nothing but A itself. Okay guys. Now next question, question number 7th, that is A or A bar. Now again this represents the total region. Okay, so if we have here a Venn diagram, this is A, so this whole portion is outside A is A bar. Okay, now the total region covered by A and its complement is nothing but 1. Now why 1? Because A is covered and the outside A, that is this region, is also covered. So the total portion covered by A and outside A is nothing but 1 itself. Okay, I hope this was clear. Now let's move on to our next set of questions. So the question number 8th is A and A bar. Now as I have told you, this represents the common part. So what is common between A and outside A? This is A and this is outside of A. Now what is common between these two? Nothing is common, so the output will be 0. Okay. Now the question number 9th. Now it is an important concept. This is A and B or C. Now let's answer it using the Venn diagram, then we'll verify it. Here we have A, and here we have B, and here we have C. So this is A, B, and now what does the question says? B or C, that is the total region covered by, let's take it as B just to make it easy. This is A, this is B. Now what does the question says? The total region covered by B or C, and what is common between A and B or C? This is the total region covered by B or C. Now the common region between A and B or C, which is nothing but this portion. Okay, this is the portion common between A and B or C. So what is this portion actually? It is nothing but A dot B, that is common region between A and B, or A dot C, that is common region between A and C. Okay, now if you distribute this dot operator over this bracket, it will be nothing but A dot B or A dot C, which is equal to the result obtained by this Venn diagram. Hence it is verified. Okay guys, I hope I was able to explain this concept. Now next question is A or B dot C. Now the answer to this is A or B or dot A or C. Now how is this true? First of all, it is also known as distribution theorem. Now let's see its proof. We'll start with RHS. Okay, now first we'll distribute the operator over these brackets. So the first one will be A dot A or A dot C. Okay, this one is distributed first. Now this one, or B dot A or B dot C. Okay, we got this. Now what we will do, first we will just write this one as A dot B plus B dot C. Okay, it is commutative. Now we will take A common from these three. So it will be A or C or B. Sorry, yeah, I forgot to mention one thing. A and A. What is this? Nothing but A. Okay, I told you what is common between A and A? Nothing but A. So the output is A. So here we have 1. Okay, now from here we can see 1 or B or C. Let's answer it using the Venn diagram. This whole portion is 1. Here we have our B, here we have our C. Now what is the total region covered by 1, B and C? That is nothing but this whole one, 1. Alright, so the output will be 1 of this bracket. Now A and 1, yani common region between A and 1 is nothing but A. So it is equal to LHS. Hence the property is proved. Okay, now let's move on to our next question. That is question number 11, which is nothing but A or A dot B. Now if you understood this one, this question will be very easy. Try stop the video and try to answer it. Now what we'll do in this question, we'll just take A as common. Now it will be A common, that is A and 1 or B. Now again using the Venn diagram, this whole is 1 and here we have our B. Now the total region covered by 1 and B is nothing but 1 itself. Alright, so this becomes A and 1. Now what is common between 1 and A? Nothing but A. So the answer is A. Okay, now let's move on to our next question, that is question number 12th, which is A and A or B. Now what we'll do, we'll just distribute this operator over this bracket, which will be nothing but A or A plus A or A dot B. We verified this one, right, in this question number 9th. Okay, we distributed here, we verified it using the Venn diagram. So we are just using that in question number 12th. Now what is common between A and A? It's nothing but A. So we are left with this. Now it becomes similar to our question 11th, whose answer was A. Alright guys, now let's move on to our next question, that is question number 13. So this is our question number 13th. Alright, now earlier we proved our distribution theorem, which was like this. Okay guys, you can remember this. We know the proof, right? We just distributed this brackets over the operators and we got this one. Alright, this is the only property that is very important, so you can remember this one. Now we will solve this question using this property. Alright, let's distribute it. It will become A or A bar dot A or B. Okay, just distributing it. Now how I have distributed this, it was A or B dot C. So A was first ORed with B and then A was ORed with C. So similarly A is first ORed with A bar and then A is ORed with B, with a dot operator inside between them. Okay, now what is A or A bar? We know this is A and this is outside A. So their ORing gives us 1. That is total region covered by A and A bar is nothing but 1. So this is 1 and A or B. Now what is common between 1 and this is A or B? Now what is common between 1 and A or B, which is A or B? It is the only portion common between 1 and A or B, so the output will be A or B. I hope this is clear. Now question number 14th, which is A dot A bar or B. Okay, now let's just distribute this over this bracket. It will be A dot A bar or A dot B. Now we know what is common between A and A bar. Nothing is common, so this will be 0 and the output will be A dot B. Okay, now next question. So the 15th is AB or AB. Now I have told you earlier, this represents the total region covered by these two inputs, which is AB or AB. Now what is the total region covered by AB or AB? It is nothing but AB. Now why I have written this? Let's suppose this is X, then this will also be X. So X or X, that is the total region covered by X itself is nothing but X. Alright, so it is computed as follows. Alright, so the next question, question number 16th and the last one for this video is A or B dot A or B bar. Now how to solve this? We'll just distribute these brackets over these operators. So it will be A dot A or A dot B bar or B dot A or B dot B bar. Okay guys, now what is this? It is nothing but A, because what is common between A and A? it is nothing but A itself, and this is A dot B bar, and this is A dot B. Dot operator is commutative, and what is common between B and B bar? That is B and outside B. Nothing is common between B and outside B, so this is 0. Okay, so we got this. Now we'll just take A common from the first 3 terms, so it becomes 1 or B bar or B. Okay, ORing with 0 gives this same term. Okay, now A is common, so we got this. Now finally we can write it as 1 or B bar is nothing but 1. We discussed this above. Now 1 or 1 is nothing but 1. Now common between 1 and A is nothing but A. So here we have our answer. So this was our last question for this video. Let's study some tough questions in our next video.